Birefringence is when a material, an anisotropic material, so one that's not cubic, um, shows two refractive indexes. So bi meaning two, refringence, refractive. So two refractive indices. And so you'll see certain odd behavior there. Now I did a demo already for the light science course where you find some calcite. So I put it on a dot on a sheet of paper, rotate it around. You can see the two beams, you can see the effects of the Polaroid sheet and all that. Unfortunately for me, I was going to do a bit more with that today, but I have access to Fraser Noble, which is the building I'm in right now, but I filmed that last term and I left the stuff in Meston. And so I don't actually have any calcite at the moment. If I get access to Meston, I've requested it, but obviously it's not viewed as essential, and we're not probably going to get access to that. But if I do, there'll be video edited in of that. If not, then this is my apology. So probably if you're seeing this, I didn't get access. But this experiment is very much observational, so I'm just going to show you a bunch of different materials and the birefringence effects. It shouldn't take that long. It's mainly just going to be pretty colors and my increasingly grotesque hands. You know, the important thing is observing the effects, and I'm going to show you the effect of strain on materials. So I have a strain gauge that I'm going to use, a very old-fashioned one, and I'm going to talk a little about, you know, the uses of birefringence in this particular way. If anyone's a geologist, leave. But if anyone's a geologist, then this is the basis, what I'm going to show you, of the petrological microscope. So I'll show you a sheet of mica, I'll show you a few sheets of mica actually. We'll rotate them around and we'll see, we won't measure, but we'll see the angle of extinction. Sorry, another good point right there. And then we're going to put different materials in and layer them. So I'll put glass in, for example, glass being non-birefringent, and then I'm going to put sellotape. Increasing layers of sellotape on glass, and sellotape is birefringent material, so you'll see the effect of that and hopefully be able to discuss it qualitatively, if not quantitatively, in your lab diary. Interestingly enough, we did this experiment 3 years ago, I think it was, and my technician at the time, Irene, who basically Robert Gordon's college pay more than us, and they hired her away. More money, less hours, and she didn't have to deal with me, so why would she stay? She bought cheap sellotape, so normally we buy the actual branded sellotape. So I guess sellotape's one of those things like Tannoy or Hoover, where like the name we use for the thing is a trademark, but I don't know, like, is it packing tape? I don't know what it's called. I'm going to look that up, and I'll put it in a little caption there. But if you use cheap sellotape, it's actually not birefringent. So she bought like 15 rolls of cheap stuff, and the students were coming to me and they were like, it's not birefringent? And I was like, yes it is, come on, you put it on, it shows. And I was like, nope, doesn't show it. So you actually weirdly need to buy decent quality sellotape if you want this to work. So again, this is one you could do it at home. Doesn't cost very much. You can buy, I was pricing this on eBay for myself because I was a little worried about maybe not even get access to Fraser Noble. And you can get a decent sheet of Polaroid that you can then cut into the pieces you need for, you know, about £5 on eBay, and then you just need a white light source. So, you know, grab that bit of glass, you know, like a standard drinks glass will do. You don't need a fancy optical plate. You can put sellotape on, you can see the effect. So if you want to do a little practice stuff, that's something you can do. But like I said, this one is mainly going to be qualitative, but hopefully you see some things that kind of explain the phenomenon. And the stuff I'm doing is actually, it's an old engineering technique, basically, because engineers would build structures, you know, miniature versions of them, out of, you know, birefringent materials, and then they'd analyze the structures under polarized light, like I'm going to do, and you can kind of see bands of strain heading across the structure, so you kind of know where you need to reinforce or where you can remove material, because obviously you've got that kind of twin concern of wanting to make a structure safe, but also not wanting to spend more than you have to on steel or whatever. And the materials that they used for the models were not always innately birefringent, but they became birefringent when strained. We'll see the same effect with the strain gauge. So this is another one where I'd suggest you write a lot of descriptive material in the lab diary. So you're trying to explain what you see, you try to relate it to the theory, and that should give you a decent mark for this component of the assessment. Okay, so we'll see how it goes.